Okay, on 3.6, we're going to look at, I'm going to work a problem just to kind of show you how to set this up to make the calculation simple. If you always want to go to, not that, you want to go to view an example and just kind of look at how they have set this up, look at the formula. Here, I noticed that you can use technology to calculate the means, just to simplify your time. But these means are pretty easy to calculate. All you would have to do, that would be 22 divided by 5, which is 4.4. You can do the mean pretty quickly, just get the average for each data set. Okay, so get the mean for X, the mean for Y, because you'll need to use this. So what I did was I kind of looked at how they set this up, and I made me a spreadsheet. And all I'm going to do is fill these in. We know how to calculate the mean. X, I, and Y are just your values. They're going to be given to you, so you just copy those over. Then you have to take your values and subtract the mean from each one. So you're going to do that for X, you're going to do that for Y, and the difference you're going to multiply together. Okay, that is the formula. If you look back up at the formula, xi minus x, the sum of those. So you're going to take xi minus x times yi minus y, and you're going to multiply those together and then divide by n minus 1. So here you can see they've gotten x minus xi y minus y. Basically, the x value minus its mean. They've taken the difference. Here's those numbers. Then they did each y value minus the mean of the y numbers. They found the difference. And then they multiply these together. And then once you do that, once you multiply those together, you sum them up. So you're going to add all those up. So what I'm going to do is I'm going to do that in a spreadsheet just to make it a little bit easier. And then what you have to do is you get this number here, and that's the sample covariance. And then you're going to find the standard deviation of X and the standard deviation of Y. That part right here, we're going to use, I'm going to do it in the stats calculator. I'm not going to do that by hand. So let's just look at it. I'll probably confuse you more there. So let me actually show you how you can do this. If you look at your values for X, they're 9, 9, 5, 5, 5. So what I'm going to do is go ahead and put 9, 9, 5, 5, 5. Okay, so we can do the mean real quick. 9 plus 9 is 18, 23, 28, 33. So 33 divided by 1, 2, 3, 4, 5. I could have done that in my head. 6.6 is your mean. So for each one of these, you would put 6.6 in for your mean. Now all you have to do is take this number and subtract. Okay, and then copy your formula down. And I'm going to delete this because we don't need it anymore. Alright, now let's fill in our y's. Our y values are 4, 8, 3, 2, 7. So 4, 4, 8, 3, 2, 7. So that's 12, 15, 17, 24 divided by 5 would be 4.8, but let's just make sure. We need to put equals. Okay, 4.8. So here we're going to have 4.8. I'm just going to copy that down. So I need to insert here. these numbers should have been, I missed a column here, so I'm making me a new column. Okay, so that's my mean. And I guess I should say the mean of y. And right here I could probably say the mean of x. Okay, so now I'm going to take yi minus the mean. So I'm going to take this minus this. And once again, I'm just following the formula, but I'm using Excel to help me organize everything. But all of this you can do on hand. You just put it in the calculator. You can make these columns on a piece of paper. I would do that, but I can't because I have to video the screen. So this is what I would do if I had paper. And these formulas, instead of putting them in Excel, I would just be plugging them into the calculator. So we're going to do this times this, the differences of each. Copy it down. Now, we have to get the covariance, we have to take the sum of these, and we have to divide by n minus 1. Well, we have 1, 2, 3, 4, 5, and if you look, I may have clicked off of our view and example, but let me show you real quick. And this view example is really good if you ever get stuck and you just need a little step-by-step guide. If you look at your n divided by n minus 1, the n is the number. Don't add all of these together, okay? How many is in each sample? 5, okay? So in our example, there's 5. So n minus 1 would be 4. So this is our covariance. Alright, so let's check that. Now theirs was a negative, ours is a positive. Okay, so that was our sample covariance. These were our sample means, and this is our, if I can click in there, this answer is our sample covariance. So this number here was our first answer. That is how you calculate a sample covariance, okay? Now we need to find the coefficient. So I want you to look at your formula. Remember, you have those formula sheets you can print off that I provide for you for your exam review. Print those off so you can keep looking at these formulas. This means the sum. I always think of roll them up, throw them in a pan. I know that sounds crazy. Add them up, add them up. That's what you're going to do at the end, is add them up, add them up. Alright, so that's what that means right there. Add them up, add them up. After you've done this here, you've taken the difference of x minus the mean of x, and you've taken the difference of y minus the mean of y, and you've multiplied each one of these differences. You're going to add these differences up, and then you're going to divide by n minus 1. It's almost like you're trying to translate a code here. Stats has a lot of junk that you have to figure out, work your way through. It's kind of like breaking the code of stats, learning that this is the summation symbol. X bar means mean. Y bar means mean of a sample. Xi means for a certain number. Like this would be X1, X2, X3, X4, X5. Okay, I got sidetracked. Let's go back to what I was trying to show you. So for the sample correlation coefficient, you take the covariance divided by the standard deviation of x and the standard deviation of y. So let me show you. Now I do want you to know how to do standard deviation. You will be expected to calculate that, but for time purposes on this, usually in a problem like this, I would probably give you the standard deviation because there's so many other calculations you have to do. Let's see what we can do here. Let's try summary stats. Let's just see what happens. Let's do X. Alright, let's try something else. Let's do summary stats. Okay. Okay, so we see that the variance, the mean is 6.6. The standard deviation is 2.19. Let's just make sure that that looks like, yes, we got 6.6. So the standard deviation of X is, I believe we said 2.9. Let's go back and look. 2.19. In your example, it says round to 2 places as needed. So I believe as you're working this, it's very important when you're doing this homework, you know exactly what they want you to do as far as rounding, because you're going to miss it every time. Yes. Okay. So as you can see here, when they plugged their standard deviations in, they were rounded to 2 decimal places. So our first one is going to be 2.19. So let's go ahead and put that in. That's the standard deviation of X. And see how it messed it up? We need to, I showed you this in an earlier video, change it so it's 2. Now we need to find the standard deviation of Y. I'm going to write SY. So let's go back to our stat crunch, and this time let's do Y, and let's hit compute. And of course I went to the wrong thing. Columns, Y, compute, and the standard deviation is 2.59. So going back here, 2.59. 2.59. I always have to double check and make sure I put everything in right. So now what we're going to do is we're going to do the formula, and that was in your view and example. The formula is 2.4 divided by the standard deviation of X times the standard deviation of Y. Now, you want this to be divided by the product of this, so put parentheses around the bottom. So we get 0.423124. We need this to be, I believe they want 2 decimal places. Yes. So 0.42. Okay, and that's all you do. Choose the correct answer below. Well, if it's positive, if it's a positive number, there is a positive relationship. It says there's a perfect positive relationship that is not 1 or close to 1. There's a positive linear relationship. If you will look at our example here, and this is something I talk about in the PowerPoint, they actually give you numbers to explain the relationship. But let me just kind of show you. Okay. Alright, the values range between -1 and 1. Alright, where X, if the coefficient is positive, it means that the value of X increases. If it's negative, the relationship is negative. So as the value of X increases, the value of Y tends to decrease. And if it's a 0, there's no relationship. Okay, and then the strengths depends on how close it is to 1 or -1. -1 indicates a perfect negative relationship, and a +1 indicates a perfect positive relationship. So you have to use this information. So here we know that it's positive but it's not perfect.